All right, and once we're familiar with the TypeScript fundamentals, let's see how we can use TypeScript with React. Before we begin, let me just mention that I assume you are already comfortable with React. So things like components, state, most common hooks, and some of the popular libraries. If you are confused about some React topics, please pause the video and utilize some external resources, since our main focus is going to be on implementing React with TypeScript. Otherwise, this part of the course will easily turn into a React tutorial. In order to follow along with this part of the course, you will need a starter project, which is the second folder in the main course repo. So if you have not already done so, get a hold of the repo, either by downloading or cloning it. And once you have the main repo on your machine, open the second folder in your text editor. So get a hold of the repo, open up your text editor, and then just access the second folder. Now it is a Node app, so same deal. We want to start by running npm install first. And also, or you know what, I'm not gonna set up such command because here and there, students complain that such command doesn't work on their operating system. So first, let's just run npm install, and then we want to go with npm run dev. And if everything is correct, again, you'll have the application on localhost 5173, and this is what you should see on the screen. And if that's the case, we can move on to the next step. All right, and let's start by taking a look at the files and folders, as well as the assets I provided. So we have node modules over here. This is where we have all of our dependencies. We have the public one. This is where we can set up some public assets. A source folder. Again, this is where we'll do all of our work, but in this case, we're going to be working with React, so we'll create components and all that cool stuff. We have the ESLint file, also a gitignore. Again, this just provides info what files and folders are going to be ignored by the source control. Index.html, this is where our root component is going to get injected. So for example, if you want to change the title, feel free to do so. A package JSON. So in here, you could take a look what extra libraries I installed. And also we can see that we have a dev one. So that spins up the dev server. And also same deal. We have over here a build command. And before Vite builds the project, what do? We compile our code. Then we have the good old TypeScript configuration file, and also a few more configuration files for Vite and also the Node one. Now, you'll also find the README over here. And just like in the first part of the course, we will use this README to set up the challenges, to take a look at the examples. I also provided some links to useful resources and all that cool stuff. And first thing that I just want to mention, essentially this project is a straight up Vite React.js boilerplate application. The difference, I just added some assets to it and removed some boilerplate files. That's it. So if you're going to run npm create Vite latest React TypeScript, so this is the name, of course you can change it, then the double dashes template and provide React.js. Effectively, this is the project you're going to get back. And like I mentioned before, most of our work we're going to do in the source. So let's just navigate over there. For starters, just like traditional React application, we have main TSX. So this is where we inject our app, basically our root component, into that div with the ID of root. Now also you'll notice few imports, but we'll discuss it later. I mean, these are just imports for some extra libraries we're going to use. Then we have the app TSX. So this is where all of our components are going to meet. You can also call this the root component. And we have a final and a star. And the way I set it up, notice these are all the topics we're going to discuss. And this is going to be our starting point. And in here, you'll find the complete code. So essentially, pretty much every time we'll start working on a new topic, we'll just import the specific folder. Because if you notice, all of them have index tsx. So this will be the default import. That's just a node thing. And then as we're moving from topic to topic, we'll just change the path over here. Now, for all of them, you'll just find this standard component where I have few heading twos, and basically I'm just displaying some text on the screen. So all of them pretty much will be the same. But of course, once we're done with the topic, there's going to be more files, more logic, and rest of the good stuff. And just to showcase how it's going to look like, let me navigate to app tsx. We want to go with import. Then let's come up with a name. In my case, I'm going to go pretty generic. I'm going to say component from. And now we want to go to a star /. And then again, we have all of these topics. And as you can see, they are numbered. So we'll start with return topic and then all the way to tasks. So let's go with 01 return. Notice again, we don't need to provide a file because all of the folders have already a index tsx. And then we want to replace it over here. We want to go with component and then render it on a screen. Again, at the moment, it's not going to change that much because we haven't set up any logic yet. And basically, as I'm moving from topic to topic, I'm just going to change over here the path. And then if you want to test something, of course, you can import the component from one of the final ones as well. Now, also something I want to mention, the idea with the React and TypeScript is following. If we want to set up components, basically Reacty stuff, we need to go with tsx. So that's the extension. Now, if you just want to set up some logic, some good old JavaScript logic, just like we did in the first part of the course, we just go with .ts. So whether you want to set up some hooks file or utils file or types file, that's the case, you'll go with ts. But the moment you set up the component, you want to go with tsx. Hopefully, I clearly explained how our setup is going to work. And if you're looking at the other files over here in the source one, we'll discuss them essentially as we progress with the course content. For example, the hooks, the store. So all of that is coming up. And I guess lastly, let me just mention that yes, I did provide some index CSS just so our examples look a bit more presentable. But again, this is totally optional. And with this in place, we can move on to our next topic, which is going to be the component returns in React. All right, so we have the correct import. Again, we're looking for *01 return. So that's where we want to navigate. And our first topic is going to be the component return. Now, let's establish a few things. For starters, what are React components? They are functions, correct? And what is the one thing that we know about function returns and TypeScript? Well, it's the fact that TypeScript infers the return type. So if I hover over, notice how TypeScript sees that essentially this is a component and the return is JSX element. So what does that mean? Well, if, for example, I'm gonna forget to set up the return, actually TypeScript is going to yell at me. So notice once I save, I have red squiggly line in app tsx. And if we hover over, we can see that component cannot be used as JSX component because it returns void. And a few things I want to mention. First, it's super helpful because when you're working on a bigger project, I mean, having no return sometimes can be tricky to spot as far as the errors go. And second one, this is something that I will probably repeat 10,000 times during the second and most likely also the third part of the course. Code error is going to be your best friend. The moment you hover over the squiggly line, or in general, the events and state values and all that, it will immediately pretty much give you all the info you need. So in our case, let's say if we go back over here and set up the proper return, we can clearly see that TypeScript infers the JSX element, which leads me to another point. Can we explicitly write JSX element in here as far as the component return? Yes, it's absolutely an option. We can go over here, even though it's already inferred, we can say, hey, you know what? I'm going to go over here with JSX element. We save it. And since in this case, I am returning a JSX element, there's no issue. Pretty much it's the same deal. But keep in mind, what if in your component, you decide that you're going to return a string? Well, now it's not going to fly because now I already have here an explicit return where I say, hey, I'm going to return JSX element. And what about null? What if I have some kind of logic and I'm going to go with null? Again, same deal. We cannot do that because we have explicitly over here this JSX element. Now, if you don't have that, TypeScript is smart. TypeScript can infer that, hey, in this case, it can be either hello, either JSX element, or null. So again, this really comes down to your preference. One option, you can simply let the TypeScript to infer the type. And at least at the very basic scenario, it's gonna help you to avoid this case where you don't return anything. Second option, you can start hard coding over here. Explicitly, what are you expecting back from this component? Just keep in mind, as your logic changes, you'll have to adjust, because if you're just gonna write all the time JSX element, well, TypeScript is going to be confused. So in this case, let me just hard code it. But for most part, I just let TypeScript to infer the type. So I'm going to go over here with JSX element. That's going to be one option. I'll say, hey, listen, it can also be null. And also, well, let's just set up a string type. Let me save it. And now notice TypeScript doesn't complain. Everything is fine because I have the explicit return and the options that I have inside of the component match to whatever I have over here in the list. So that's how we can set up component returns in TypeScript. All right, and up next on our list, we have, I believe, props. So first, let's change the path. So we're looking for 0 to props. Let's take a look at the browser. Yep, we have React, TypeScript, and props. So looks like everything is correct. And essentially in here, in the component, let's just provide some values. So we're going to go with something generic, for example, name and the ID, which is going to be actually a number. So 1, 2, 3. And immediately, once we add those values, TypeScript will complain. Because again, it's like setting up a function, providing the arguments, but we haven't set up the parameters. So TypeScript doesn't know what to expect. So let's navigate right now to our props index DSX. And let's take a look at the multiple options we have for props. And essentially the first one is the inline one. Remember, in React, props are gathered in this object, which we access either by just destructuring it over here, where we go with the curly braces, or we go with props. Now, I'll show you the other option a little bit later. For now, let's just grab the object, the props object, and let's explicitly take name and the ID. So those are the two values we're looking for. But before we can do that, since we're working in a TypeScript, yep, just like regular function, we'll need to set up the type. And the first option we have is basically set up everything inline. Now, I can tell you right away that it's most likely not going to be your approach, especially for bigger projects where you have components with a bunch of props, because it's just going to be very messy. So yes, in here we'll start nice and easy, but in a second I'll show you also another approach that we can take. So in here, we just say, hey, listen, name is going to be a string and the ID will be a number. And the moment we do that, TypeScript should be happy. It's just complaining that we haven't essentially used it yet. Now, notice how everything's fine in the component. For some reason, it's complaining over here. So let's try to use these values and let's see whether that makes TypeScript happy. So I'm just going to change it around. I'll say heading 1. Now that one will be equal to name. And we're looking for our name value. And then the second one will be heading 1, and we'll just provide the ID. So let's go with ID, and then let's access that. Let's save this. And if everything is correct, we should see name Peter and whatever ID we provided. Again, we just go back to the fundamentals section where we learned that every time we have a function, we need to provide info to TypeScript. What is this function going to receive as far as the argument? And since props are essentially arguments that we pass in, when we construct the component, we need to provide the type annotations. And what's really cool, let's say that we're using this component in multiple places in our project. If for some reason I'm going to forget to provide one of the props, notice how immediately TypeScript is going to complain. So I won't have to realize this error at runtime. As I'm building the project, let's say that I'm setting up this component somewhere and I just forget that I also need to provide the name. TypeScript will immediately let me know that something's wrong. And actually the same works if I decide that the name is actually going to be title. I mean, it's quite common to have a component and you think that, yeah, the name for the prop name is awesome, but then you realize that, hey, you know what? Actually, prop name should be title. Let's say I do that. Notice how immediately in all the places where I'm passing in the wrong prop, it's going to light up. So again, imagine a scenario where you have this component in multiple places in your project. Immediately, you know that something is wrong. Again, something super, super cool where you don't need to run around like a headless chicken and then look for those instances. You'll immediately know where you provided the wrong prop. So let me set it back to name and ID. And up next, we're going to discuss alternatives to inline type annotations. Okay, so our initial setup works, but what if we have a long list of props? Or let's say we want to reuse these props. Well, in that case, we can either set up the type or the interface. Again, this is totally up to you. I'm going to stick with type just because it's my preference. I'm going to call this component props. And in here, we just want to provide pretty much the same values. So actually, you know what? I can just cut it out, remove these curlies, set it equal to, and then where I have my destructuring, I just want to set it equal to my component props. Save it. And since I don't see any red squiggly lines, I'm good to go. Now, also please keep in mind that alternatively, you can just reference the props. So in here, I can say, yeah, props is going to be equal to component props instead of destructuring name and ID. And then every time I want to access one of the values, I can go here with props ID and props name. Again, this really comes down to your preference. Some people prefer the props option and some people prefer this option. As long as you don't have the red squiggly lines, as long as TypeScript is not complaining, it does really come down to your preference. And the same goes for the type or the interface. So if you want to use the interface over here, you can definitely do so. If you prefer type, it's definitely an option as well. And while we're still on the topic of props, let's also discuss the special children prop, which allows elements and components to be passed into other components. So if I'm going to go to app DSX and set up my closing tag as well, and then let's say add a heading 2 with a hello world, TypeScript is going to complain because I haven't specified that I'm going to provide the children prop. Now the name is exactly the same, so that doesn't change. We just go over here with children. And yes, we do want to render it somewhere in our return as well. But now $1,000,000 question, what is the type? And essentially we have few options. We can hard code it ourselves. And the type we're looking for is React node. And we can import it, or we can just go with React dot and then React node. So for example, this is one option we can take where we go with React dot and then React node. So that's the type we have access to. And the moment we do that, we fix the first error. But notice right now, TypeScript is complaining because since I set up my children prop in the props component, it's also expecting the same thing over here. And one easy way how to fix that is to just make this one optional, just like we covered during the fundamentals part. So I can just go here, say that, yeah, children might be provided or not. And if it's provided, then it's going to be a React node. Now, also a quick side note, just like with vanilla JavaScript, actually during development, everything is going to work, even though we have the error. But please keep in mind, you won't be able to build the project unless you change some configurations and allow the project to be built with the TypeScript errors. Hopefully that is clear. So let me go back to this optional property and let me show you another way how we can handle the children prop. Alternatively, we can also import a special type from React, which is called props with children. So yes, we have access to a declaration file where there is a type called props with children, which actually is going to handle the children prop for us. Now, in order to import it, we're going to go over here with import. Now I will add this type. Remember, technically it's not a must. Then we're looking for props with children, and this is going to be coming from React. And if we hover over, we can nicely see the type definition. And this is where I would encourage you to stop the video and go over this logic and try to see whether you're able to understand everything that's happening under the hood, since we have covered all of these things during the fundamentals part. And again, reading such type definitions is going to be a good practice for us, not only to jog our memory as far as TypeScript, but also to understand what is the specific type or function or, I don't know, property actually doing. And if we take a look at the type definition, we can see that props with children is a generic, which again, kind of makes sense because it's going to be used in a lot of situations. So there's going to be the case where the component props has one shape, and then in the second component, the shape might be totally different. So again, a very good use case for generic. Now, by default, it's actually going to be set equal to unknown. So this will be the default value. And then notice how they use this intersection type. So essentially, whatever is passed over here is just combined with what? With children property, which is set equal to optional. So it might be passed, might not. And the type here is going to be equal to React node, or it's going to be equal to undefined. So let's try it out. I think I'm going to leave this one for your reference. So let me just copy and paste. Let me comment out the first one over here. And then instead of setting up the children property ourselves, we'll just go with props with children, and then we'll provide this value over here. So effectively, it's going to look like this. We're going to go with props with children. Remember, it's a generic, and it's looking for that type. And the moment we do that, as far as the result, notice we get back whatever type we pass in. and it's just combined with this children property. And with this in place, now I can go to the app, remove the heading 2, or provide the heading 2 to the second instance, and everything is going to work, and TypeScript is not going to complain. So again, when we work with children prop, we have few options. Either we can explicitly provide the value of React node ourselves, or we can import the props with children, which essentially does the same thing behind the scenes. All right. And once we're clear on component returns, props, up next, let's talk about state. So first we want to change the import, and this is actually going to trigger some TypeScript errors. So I think I'm just going to go with good old component for now. So let me render the component. Yep. TypeScript still complains because we haven't changed the import. So we're looking for a 0-3 state. And now we render the component. So now let's navigate to this particular component. And let's just, I guess, set up heading 2 with some kind of value, as well as the button, because inside of the onClick, we'll try to change the state values. So I think I want to do that first, and then we'll worry about the actual logic. So in here, inside of the div, I want to go with heading 2. I'll add one of the classes. So margin bottom is going to be set to 1. And I guess I'm just going to leave this one over here. Then let me go with a button. Let me remove this heading 2. And let me add some classes just so we have some basic styling. So btn center over here. And then let's just right click me. And eventually we will set up the onClick. Let's not worry about it right now. This is what we should see on the screen. Now, I don't know whether you remember, but actually we already covered sort of the use state during the fundamentals. We talked about it when we discussed the generics, but let's go over it one more time. So yes, we can nicely use state in React to control the local state. But if we take a look at use state, it's actually going to be a generic. So let's start, I guess, with the import. So looking for use state. It's coming from the React. And let me just hover over it. Notice this is going to be the type definition. It's a function. It's a generic. And essentially, we can either pass in the initial state or we can pass in the function. And as far as the return, notice it returns the value we provide in the initial state and the function that controls it. So where I'm going with this, if we have just primitive values in the use state, you'll see that TypeScript is very smart and it's going to infer the type. So for example, if I'm going to go over here with text and set text and set it equal to my use state, I don't need to set up over here the type and say that it's going to be a string, because TypeScript is going to know that. So if I'm going to go here with shake and bake, and if I'll hover over the text, notice TypeScript knows that it's a string. So essentially, whenever I will try to update this value, it's going to expect the string. And we can actually see that over here. If we go with onClick, and let's not worry about how we can handle events in React. We'll cover that a little bit later. For now, let's just pass in our arrow function just so we can invoke setText. And if I'm going to provide a wrong type, it's not going to work. So notice again, as we're hovering over, what is the setStateAction function looking for? It's looking for type string. So it's going to be okay if I go here with TypeScript. Yeah, there are no complaints. But if I'm going to provide the number, immediately TypeScript complains. Again, the logic technically is going to work during development. I can navigate over here, press, and technically I shouldn't have any errors in the console. Nope, everything is fine. But TypeScript is not happy with me. And the same is going to work if, let's say, I'm going to set up the number. So let me navigate over here, and instead of text, we're going to go with number and set number. Okay, good. And then we'll provide the primitive value over here. And you know what? Let me just comment this one out for your reference. If we're going to go with set number, again, we can see that set state action function, which essentially is a type for this one, for our set number function in this case, is expecting a number because TypeScript is going to infer the type. If I'm going to provide it, if I'm going to say 23, yeah, everything's awesome. If I'm going to go with some kind of string value, it's not going to work. Now, it doesn't stop me from explicitly going over here and saying number. I mean, we can still definitely do so. But again, the whole point is that TypeScript is going to do a very good job of inferring such type. Now, it's going to be a different scenario if, let's say, we have empty array as our initial value. So let's say we have over here a list, then comma, and set list, and we set it equal to use state and empty array. Notice how TypeScript essentially sets list to an array, but the type is equal to a never. And at this point, we have a few options. Either we provide some values over here, so TypeScript knows what the type is going to be. So for example, I can go with hello, but keep in mind, there are instances where you want the default value to be empty array. So I'm not going to provide some random hello just to make TypeScript happy. So the solution in this case is to use the generic approach, where we know that useState is in a generic, and we'll just say, all right, yeah, it's an array, but it's going to be an array of strings. And at that point, if I'm going to go to my onClick and go with my set list again, my function, everything is going to be awesome if I'm going to provide the strings over here. If I'm going to go with hello, and maybe I'll also add over here world. So this is going to fly because I have strings in my array. However, if we're going to change this around and we'll go with 1 and 3, notice TypeScript is not happy because it's expecting a type string. So this is how we can work with use state and TypeScript. By default, TypeScript is going to infer the type, but it is a generic, and there's going to be instances where we'll need to explicitly provide the type that we expect for the value, and automatically it's going to be set for the set function as well. Okay, and up next, let's cover an example where we have a list of objects. Now, in my case, I'm going to create nav links, but again, the actual data is totally up to you. So I'm going to go with a nav links. That will be my array, and I'm just going to provide some dummy data. And yes, I will, in the beginning, rely on the fact that TypeScript is going to be able to infer the type. So in here, I'm going to go with ID1, then URL. I'll just type some URL. So essentially, it's going to be some kind of string. And also text will be some kind of text. So some text. Okay, let's save it. Then we want to copy and paste. So 1 and 2. Let's just change these values over here. 2 and 3. And I don't think I'm going to change any of the actual values. I don't think it's relevant. Now I do want to set up the type. Type will be equal to a link. I'll say that ID is a number. Okay, awesome. Then URL will be a string, and then text will be a string as well. Let me save it. I'm not gonna set it up over here. This is something we're gonna do later. And now let's see how we can work with that in our use state. So in here, I'll call this links and set links. That will be my function name. We're gonna go with use state for now. Let's not set the type explicitly. And now let's just provide the nav links. And again, TypeScript is super smart. Now it knows that essentially links has this shape. And essentially we can go over here where we have our own click. We can invoke set links. Let's say that I just want to add it to an existing array. So I'm going to spread out all the current links and I'm going to try to add a new one. If the values I provide don't match the signature, you'll see that TypeScript will complain. So if I'm going to go with ID 4, then URL is going to be equal to hello, and then also a comma. And I'm going to go with, I don't know, what was the last one? I believe it was text, right? If I'm going to say hello, yeah, everything's awesome because this matches the signature. However, if I'm going to omit the text, notice TypeScript immediately is going to complain because the text property is missing. So all of this is nice. The problem becomes this is inferred. And remember, when TypeScript infers something, it infers based on what? On the original value. So for example, if I just go and comment this one out, now notice TypeScript thinks that, yeah, links technically can be an array of objects with this shape or with this shape where text is actually missing. So now if I'm going to go here, I'm actually going to be successful. So this is a good use case where we want to go with our angle brackets and we want to say, yeah, we have these links over here, but actually the type is going to be following. It's going to be an array of link type. So now TypeScript is going to complain. It's going to say, hey, listen, whatever values you provided, they don't match. So we need to fix it over here. And now the same deal is going to be in our onClick as well. We'll have to provide, I believe it was our text one. Now, lastly, I just want to mention that technically we can avoid all of this debacle pretty much if we just go with our type annotation over here and we say with the link. Then, of course, I'm not going to be able to remove the property. But keep in mind, there's going to be some instances where you're not going to be setting that data. So again, that's why it's super useful to use the angle brackets and to explicitly let TypeScript know that the shape you're expecting is going to be following. And that way, essentially later when you need to update, it's going to be very hard to provide the wrong data. And up next, let's see how we can handle events in React. For starters, we want to change the import. So we're looking for starter and the number 4 events one. The component is not expecting anything because we just have the bare bones setup with the div and all that. And initially, I just want to set up 2 controlled inputs. One is going to be for text and one will be for email. And of course, in the process, you'll see why we have 2 of them. So let's do that. Let's go with use state. That is coming from React. Awesome. Then let's go with our text and email. And yes, I will rely on the fact that TypeScript can nicely infer the primitive types. So I'm just going to go with empty value. That will be my string. And the same is going to be for email. Let's provide the name here and let's go with email. Let's save this. And now we want to set up 2 inputs inside of the form. Again, just for better styling and all that, I'll wrap this into a section. Then we'll provide a heading 2. I'll call this events example. And we want to go with our form. For now, no action. Don't care about that. But we do want to add a class of form. And inside of it, let's go with input. Type will be equal to text. Let's just add a few classes here. We're looking for form input and margin bottom is going to be set to 1. Since I'm creating over here a controlled input, I'm going to go with value and on change. So let me go with value. So that will be equal to my state value. So I'll set it equal to my text. And then also we have on change, which essentially controls that value. So we're going to go over here with on change. In here, I'm going to pass in the arrow function. And remember, we have access to the event. And now let's go with our set text. And let's pass in event.target.value. So again, this is typical setup for controlled inputs in React. There's nothing really unique. Now we want to copy and paste, and we want to set up one for email. The difference, we're not going to use the arrow function. We'll actually set up the function reference. So type, yep, still equal to, or you know what? No, it's actually going to be email. Then the class name form input, yeah, that stays the same. Value will be email. So this is coming from the state. And also on change, like I said, there will be a reference. So you know what? For now, I guess let's just remove it, even though most likely it's going to complain. Then let's go with our button, and just for kicks, let's go with type and let's set it equal to submit. Then let's add some classes, btn and btn block, and let's write over here submit. And actually, this is something that we covered previously when we worked on the tasks application during fundamentals. You see, in here, when we provide the arrow function, Typescript will nicely provide the value for the event. As you can see, it's react dot change event. So that's the type we get from our declaration files. And it's a generic. And essentially, we provide over here the element, the HTML input element. And this gives us a good clue what we need to provide over here in the function reference. So if I'm going to navigate up and I'm going to go with const and then handle change function. And if I'm going to try to access the event, Typescript is going to complain and it's going to say, hey, listen, this is type any. So for now, let's not worry about it. Let's just go with event.target.value just so you can see that we can access that. And let's also go with our set email. And we want to provide the same value. So event.target.value. Now let me navigate to my browser. So at the moment, it's just complaining because we haven't set the on change. This is our form. Notice I can provide the value, but I cannot do the same for the email. And in order to provide the correct type, again, we simply want to reference what we have over here. So notice this change event. We want to go with event, then react dot, and then we're looking for the change event. And if we take a look at the docs, if we take a look at the type definition, we can see that change event type is a generic. It's expecting a type, which is going to be the HTML element. And the default value is going to be element. Now, what we get back is target. And that will be the intersection type between the event target and the type we provide. So now let's navigate back to our index DSX and set up the angle brackets and provide the correct element. So we're going to set this change event on HTML and input element. So now we have access to the target as well as the value. So this is what we need to do when we set up the function as a reference. Again, if we just provide the inline one, everything is going to be set already for us. So now let me just navigate over here and we're going to go with on change and we'll set it equal to handle change. And with this in place, Typescript doesn't complain. And also we have the correct values in the browser. So let me go over here. Notice I'm able to provide the value and the same is going to be with my email. Okay. And while we're still on the topic of events, let's cover submit event and few things we need to be aware of when we work with form data API. So let's say we want to handle the form submissions. We know that in React, there's on submit and same deal. We can either pass in the inline function or we can set up the reference. And just like with on change event, essentially, if we pass here the inline, Typescript will right away infer the correct type. If we set up the function reference, then we'll need to do it basically manually or ourselves. And you'll see that the form event is very similar to change event. It's also going to be a generic, and we'll just need to provide the correct HTML element. And I think I'll right away set up the function reference. But you know what? Before we do that, let me just mention that in between the videos, I added 2 attributes, one on each input, and it was the name attribute. So in here, I just set the value for text and in here for email, simply because we will use the form data in this video as well. And in order to access those values, we need to add those name attributes. Now, I'm fully aware that these are controlled inputs. So technically, when we submit the form, we can access both of these values directly. But I do want to showcase some things about form data, and therefore I added these attributes. So if you want to follow along, I suggest you do the same. So like I said, I'll right away set up the reference. Let me go here with on submit, and I'm going to set it equal to handle submit, a function I don't have yet. So let me go with handle submit. And what is typically the first thing we want to do? That's correct. We want to prevent the default. So for now, again, I just pass in the event. And since TypeScript has no idea what I'm talking about, it's going to complain, and it's going to say that the parameter is any. So first, let me just set up the logic, prevent default. And if we want to get the type again, we can always use the editor as our best friend. So notice, essentially, we have over here the HTML form element, and then we're looking for form event. Or you can pass in the inline and you'll get the exact event type. So in here where we have the event, we want to go again with React, or we just import this type. Then we're looking for form event. It's a generic, and in here we simply pass in HTML, form, and element. And now we have the correct type. So now we can use all the properties and methods, and TypeScript is going to be happy and not going to complain. Now, as far as form data, it's a nice interface to handle a case if you have a bunch of form inputs and you don't want to deal with controlled inputs. So you don't want to set up the state variables. You don't want to set up the on change as well as the value. Then it's pretty straightforward. Just set up the form, add those name attributes, and you're good to go. Once you submit the form, you'll have access to it by creating a new instance of form data. So in here, we want to go with const form data. We want to set it equal to new form data. So this is right away available to us. We don't need to do anything. And then if you don't work with TypeScript, essentially we have 2 options. We can either go with event.currentTarget, and notice how with TypeScript we can do the same. TypeScript is not going to complain. However, if we're going to go with event.target, which again we can do without TypeScript, actually it's not going to work if we use TypeScript. So let me just comment this one out for your reference. And actually, I'll use this one later on anyway. But if we go here with event.target, it's not going to fly. So TypeScript is going to complain. Now, a way around that is to basically go with HTML and then provide form element. So we just add this type assertion where, yeah, we're looking for event.target, but we say that, hey, listen, this is going to be actually a form element. Now, if we go with current target, TypeScript is smart and it can see that we already have this element over here. So let me, like I said, comment this one out and actually use the current target. And then one more gotcha about form data. Potentially the values could be null as well, and we need to handle that. So how does that look like? Well, for starters, let me just showcase how we can nicely access all of the values. So if we go here with object dot, then from entries. So now we just need to provide the form data and we'll get access to all of the values. So if I go with data, then let me refresh and provide some values. So some name and email at email.com. Let's see what we get back once we click on submit. Notice we'll have this object, and even if we have 15 inputs, we'll have a object with 15 properties with all of the values over here. And as far as the gotcha, well, let me first create a type just so we can clearly see that. So let's say we have over here type person is equal to, and then name, and that will be equal to string. So pretty straightforward type. And then let's go here with const person. Let's set it equal to our person type. And we're going to go here with name. And now let's get the value. Now it's going to be the same for the object over here, for the text property inside of this object. But first, I'll just showcase what happens if we use the formData.get method, which is available to us. So let's say I only want to get the text value. I can always go here with text equals to formData, then dot get. Then we need to provide the name, and the names need to match. So let's say in this case, I want to access the text. Notice the value that I'm getting back. Either it's going to be formData entry value type, or it's going to be null. Now, why do we care about that? Well, if I'm going to set my name equal to a text, Typescript is not going to be happy about that. It says, hey, listen, potentially it can also be a null, and you cannot assign this value to a string. So the way around that is to, again, use the type assertion, where essentially we go with as, and then we set it equal to a string. And here, again, I'm telling Typescript that I know more about the project, where, yeah, maybe this can be null, but in this case, I know for sure that value is going to be correct because I know that these two values match. And now notice how everything works. And the same is going to be over here. Let's say if we go with data.text, remember that was the property name. Again, it's not going to fly. So in that case, we again need to go with as and then string. And now Typescript doesn't complain. So just to recap, whenever we set up events in React, if we provide the inline function, everything is inferred as far as the event type. So there's really not that much difference between Typescript or no Typescript. However, if we set up functions as references, then we'll need to provide the correct type for the event. And there are two things that we're looking for. We first need to grab the correct event type, and also we'll need to provide the correct HTML element, since most of these events are actually generic. Now, if we want to get the quick suggestion, we simply can set up the prop on the element and then provide the inline function. And the moment we do that, we'll get a nice suggestion with the correct event type and the correct HTML element.